In number one, we have a parabola and we want to find the vertex. So we know that the x-coordinate is given by minus b over 2a. So that's minus 12 over 2 times 2 minus 12 over 4, so minus 3. So that's the x-coordinate. And for the y-coordinate, we're just going to substitute in. So we have y equals 2 times minus 3 squared plus 12 times minus 3 minus 1. So that's 2 times 9 minus 36 minus 1. 18 subtract 36 subtract 1. Minus 18 minus 1, that's minus 19. So the vertex, negative 3, negative 19. And number 2, we want the quadratic equation with this vertex and through this point. So we're going to use the standard form that contains the vertex. Okay, so it looks as follows: a x minus h squared plus k, and the vertex is hk. So we have f of x is equal to a. Here's our h, here's our k. So we have x minus 3 squared plus 4. And we just have to figure out a, and that's where this point comes in. We're going to substitute x and y. So here we're going to substitute a 1, and here we're going to substitute a 12. So we get 12 is equal to a times 1 minus 3 squared plus 4. So 12 is equal to a, and this is a 1 minus 3 is minus 2 squared is 4. Subtract 4 from both sides. 8 is equal to 4a. Divide by 4, a is 2. So let's complete this. And we have f of x is equal to 2 x minus 3 squared plus 4. Right, number 3 says at most how many turning points does a polynomial of degree 7 have? Well, that's easy. It's 1 less than the degree, so the answer is 6. Okay, now we want to graph this function x squared times x squared minus 9, and we want to get some information: x-intercept, y-intercept, and behavior, and plus minus analysis. All right, let's first finish factoring this. So we have x plus 3, x minus 3. So right away from this factored form, we can get the x-intercepts. So we have x equals 0, x equal minus 3, and x equal to 3. So those are our x-intercepts. And we get the y-intercept by setting x equal to 0, and we will get 0 on the right-hand side. So y is equal to 0. So that's the y-intercept. All right, let's do the plus-minus analysis. All right, let me just write that: plus-minus analysis. As x goes to infinity, what's the leading term here, the highest degree term? If we multiply through, we're going to get x to the 4th. So this is x to the 4th plus smaller degrees. So as x goes to infinity, x to the 4th goes to infinity. And as x goes to minus infinity, x to the 4th also goes to positive infinity, and that's because of the even exponent here. So the end behavior is up on the right, up on the left. All right, so now we're ready to graph. And let's do that. We can do the graph together with the plus minus. We'll put in the x-intercepts. So we have 0, we have 3, and we have minus 3. Now, notice because of the x squared, actually I see I forgot to include that here when I factored. Let me put that back, that x squared. Because of the x squared, this one has multiplicity 2, so it's a touching point. All right, so this is a touching point. Maybe I'll just put a little circle around here, just as a light circle, just as a reminder. All right, so like I said, this is going to go, end behavior, we're going to just indicate that here, up on the right and up on the left. And now we're ready to weave through the zeros. We're just going to go around through here, down, go through here, over to X. Don't go through, just touch, down and up. All right, let's verify this with the plus-minus analysis. So the plus-minus analysis is going to be in between the zeros. The zeros are 3, 0, and minus 3. So if we substitute in something like 4, for example, then here, this is always positive. It's squared. This is positive. Everything's positive. So we have positive here. How about a 1? Between 0 and 3, a 1. Okay, so positive, negative. So negative here. How about a minus 1? Positive, negative, negative again. So notice the sign didn't change to the right and left of 0, and that was because of the x squared. All right, how about something like minus 4? Minus 4 would be negative here, 2 negatives, that would be positive. So that just confirms what we thought about the graph. Now let's weave through the zeros. So now here the graph is positive, that's what it says. All right, and it's changing to negative. We're going through this intercept. Negative. We have to come back up to this x-intercept. We're only going to touch it because the graph is staying below the x-axis, negative, negative. And then we're going to go up like that through this last intercept. And that's a sketch of the graph. Number 5, we're going to graph a rational function. So first, let's factor out the 2 from the numerator. We get the x-intercept from the numerator, so that would be x equal minus 2, and so that's the x-intercept. And we get a vertical asymptote from the denominator, so that would be x equals 3, so that's vertical asymptote. Let's do end behavior. No, let's do y-intercept. So we're going to set x equals 0, so we have y equal that's 0, so we have 4 over minus 3. And now let's do end behavior. As x goes to infinity, we have 2x over x. That's equal to 2. And minus infinity, we have the same thing. So we have a horizontal asymptote at y equal 2. All right, so let's do our graph. We'll put in the x-intercept, minus 2. Let's put in the vertical asymptote at 3. And the horizontal at 2. Okay, now let me put an open circle over here. All right, we can do a little plus-minus analysis between the zeros of the numerator and denominator. All right, if we plug in a 4, everything's positive. If we plug in something between here and here, like 0, if we plug in 0, we have a negative. And if we plug in minus 3, say over here we have negative, negative, so that would be positive. Okay, so that means that this vertical asymptote, our curve is going up, so we're going to draw it going up, and we're going to have it level off at the horizontal. Here everything is negative, so our curve is going down. It's going to go through that y-intercept, which is, let's say, about here. That's the minus 4/3 y-intercept. It's going to go there. It'll go through the y-intercept. It'll go through the x-intercept, and it's going to level off. All right, that's a little bit crooked, but it's going to level off at y equal 2 at this horizontal asymptote. So that's more or less the graph, not drawn very well, but that should go through here. And number 6, we want to find horizontal and vertical asymptotes. So let me just rewrite this. This is f of x equal 3x squared minus 5x plus 6 over x squared minus 4x minus 5. So to find vertical asymptotes, we're going to just factor this denominator. So this factors as x minus 5x plus 1. All right, check and make sure that's the correct middle term. So we have vertical asymptotes minus 5, minus 1. Those are our vertical asymptotes at x equal minus 5, x equal minus 1. Okay, let me just, I don't have to factor the numerator. But now let's do end behavior. So as x goes to infinity, we're looking at 3x squared over x squared. And minus infinity is the same. 3x squared over x squared equals 3. So we do have a horizontal asymptote. Y equals 3. In number 7, we're going to do synthetic division. And we're going to divide x plus 2 into this. So we draw a little box. Since this is a plus 2, we put a minus 2 here. And then we're going to write the coefficients. The coefficients here are 1 for x to the 4th. X cubed is missing, so put a 0. Minus 3 for x squared. X is missing, so put a 0. And 1 for the constant. So that's 4 x to the 4th, x cubed, x squared, x, and constant. All right, put a line, bring down the 1, and start multiplying. Minus 2 times 1 is minus 2. Add, we get minus 2. Okay, keep multiplying. Here we get plus 4. Add, and we get a 1. Multiply again, we have minus 2. Add, and we have minus 2, multiply again, and we have 4. Add, and we have 5. So that's our remainder. And we're going to get a polynomial beginning with x cubed, since we divided x to the 4th by x. So we're going to get 1 degree less. So that would be 1 times x cubed minus 2x squared plus 1 times x minus 2, remainder 5. All right, let's sketch this graph, y equal 2 to the x, and we'll write down the domain and range. So it looks like this. All the exponentials go through 0, 1. That's because 2 to the 0 is equal to 1. It goes up on the right, and we have this leveling off on the left at the x-axis. The domain, the x values are greater than minus infinity and less than infinity. And the y, everything is above 0, so that would be y greater than 0. Okay, domain and range and graph of y equal ln x. Let's remember that one. Ln x goes through 1, 0. It goes up gradually, and we have a vertical asymptote. The domain, everything's to the right of 0, so the domain is x greater than 0, and the range is x greater than minus infinity, less than infinity. This graph is slowly going up to infinity and going down to minus infinity. All right, now let's sketch this graph. Okay, so first let's look at y equal log base 2x. It pretty much looks the same as ln x. It goes through 1, 0, goes up slowly on the right, and that same vertical asymptote along the y-axis. All right, so what we're going to do is first we're going to move it, well maybe we'll do it in one shot. We're going to move it left 1 because of the x plus 1, and also up 3 because of the plus 3. So let's redraw. First left 1, so this vertical asymptote is going to minus 1. That's left 1. This point 1, 0 is moving over to 0, 0. All right, and let's draw that vertical asymptote coming down. We'll go through 0, 0 and up. So this is actually the graph of, all I did was the left one. So let me cross off the up 3. I didn't do that yet. Okay, let's now do the up 3. So we're doing it in 2 stages. Okay, up 3, we still have the vertical asymptote at minus 1. This point we're going to add to the up 3, we're adding to the y-coordinate, so it's going to 0, 3. All right, so let's redraw this picture. We're going to draw that vertical asymptote and then the graph going slowly up. So that's the graph of y equal log base 2 of x plus 1 plus 3. Okay, let's look at y equal 2 to the x plus 1 minus 1. All right, so let's remember just quickly y equal 2 to the x. 0, 1, up on the right, down on the left. Leveling off. All right, let's do left 1. So that would be y equal 2 to the x plus 1. Left 1, so this point's going to minus 1, minus 1, 1. We just subtract from the x. Subtract 1. Okay. So here it's going to start leveling off, and here it's going up. And now let's do down 1. For y equal 2 to the x plus 1 minus 1. All right, so it's important to put in the new horizontal asymptote where the graph levels off. So it's going down 1, so it's going to level off at y equal minus 1. All right, what about this point? Down 1, so it's going to minus 1, 0. So we're here. All right, so this is minus 1 comma 0. It's on the x-axis, and here the graph is going to level off, and here it's going up. We want to find the x and y intercepts. Well, here's the x-intercept, minus 1, 0, and let's find this y-intercept. So we'll find the y-intercept by setting x equal to 0. So y is equal to 2 to the 0 plus 1 minus 1. That's 2 minus 1, which is 1. So this is the y-intercept is 0, 1. Let's find the x-intercept another way also. So to find the x-intercept, we set y equal to 0. So let's do that in the equation. So we have 0 is equal to 2 to the x plus 1 minus 1, or 1 is equal to 2 to the x plus 1. Now, 1 is 2 to the 0, so we have 2 to the 0 is equal to 2 to the x plus 1, and then we would just pick off those exponents and write x plus 1 equals 0, and we get x equals minus 1. So we can get it algebraically as well. In number 12, we're sketching the graph of y equal minus 1/2 to the x minus 2. So first, let's remember what this graph looks like. All right, this is really the same thing as 2 to the minus x. And I mention that because when x is replaced with a minus x, it's a reflection through the y-axis. So remember, this is what, I'll just draw a little dotted line to indicate where 2 to the x is. So if we reflect through the y-axis, 2 to the minus x would look like this. It goes up on the left and down on the right, and it goes through the point 0, 1. All right, let's use this as our starting point. And now let's move to the right 2 to graph y equal 1/2 to the x minus 2. All right, let's add 2 to this coordinate. So this point moves to 2, 1. All right, so the graph is going to go down to the right, to go down on the right and up on the left like this one does. All right, and now let's finish this by reflecting. The negative in front would indicate a reflection through the x-axis. So this graph is going to sort of spin around over to here. So let's do that. So now we're doing reflecting through the x-axis. Okay, so this point is going to change to 2 comma minus 1 when we reflect. And that's basically the picture. Okay, so this is the graph of y equal minus 1/2 to the x minus 2.